to explain the the last two questions on the topic one, which I believe those are the ones that you guys are having more trouble with. Remember that you have to submit all of these corrections on week 5, which is the last week on the Wednesday. Okay, so these are the values that I have for my porosities in the topic. And the first questions are going to be calculate the mean, and then the median, and then the mode. Okay, but the mean, hopefully you guys calculated it correctly, right? Add all of those numbers and divide by the total amount of values, which is 7 values, right? We have 7 values, and you're going to get 22.3. So just to make it a little bit more easy to explain, I'm going to round up to a very small number of decimals, okay, a very few decimals. So when you're doing this actual calculation for the revisions, make sure that you're not rounding up any of the numbers, okay, that you keep the most decimals that you can, because this is going to make it be a very, very accurate result. So the first thing that we're going to do is calculate the mean, 22.3, and then we're going to calculate the standard deviation. Okay, so the formula for the standard deviation, this sigma represents standard deviation. It's going to be the square root of the sum. So we'll have to add some number from all of those values of the difference between the value and the mean squared. So we're going to make a difference, but don't worry about the sign. That's why we're going to square it. And this is going to be divided by the degrees of freedom. Degrees of freedom is the total number of values minus 1. Okay, so let's start with the inner part of the parentheses. This is the first thing that we're going to calculate. X minus, or the value minus the mean. Okay, so my first operation is going to be 21 minus the mean, which is 22.3, and then 18 minus the mean, then 21 minus the mean, 28, and we're going to do the same thing for all of the values. Okay, so that's the first thing, x minus the mean. Okay, 22.3, 25 minus 22.3. So let's see what the results are going to be. If they're positive or negative, it doesn't really matter. Okay, so the first result is going to be negative 1.3, and I believe this is also going to be negative 1.3. Negative 1.3. The second value is going to be negative 4.3. That's for the 18. For the 28 minus 22.3, it should be 5.7. That's for 28. For 22, 22 minus 22.3, that should be negative 0.3. And the last value, 25 minus 22.3, this is 2.7. Okay, so those are the first results that we need in order to calculate the standard deviation. The next operation is that result that I just got, I have to square it. So I have to multiply it times itself. Okay, this is going to get rid of the negative signs. So 1.3 times 1.3, that's 1.69. Then 4.3 times 4.3, this is 18.49. Then 1.3 times 1.3, and 1.3 times 1.3. 5.7 times 5.7 is 32.49. Remember that you're going to keep all of the decimals, right? So 0.3 times 0.3, 0.09, and 2.7 times 2.7, 7.29. Okay, so you're getting all of those values squared. The next thing that we're doing, trying to calculate the standard deviation, right? This is going to be the sum of all of those values. So I will have to take all of those values and add them up, see what the result is. Okay, so I'm going to add them up really quick. That's 1.69 plus 18.49 plus 1.69 plus 32.49 plus 0.09 plus 0.69 plus 7.29. The result is going to be 63.43. That is the sum. So we're trying to calculate the standard deviation in this case. Okay, so this number represents all of this. That's 63.43. The next thing is that we are dividing by the degrees of freedom. So n minus 1 is the total values minus 1, right? So n minus 1 is the same thing as 7 minus 1, which is equal to 6, right? So if you divide this number, I'm just going to do the division sign so we don't confuse that. We divide by 6, the result is going to be 10.57. Okay, so this 10.57 represents the whole thing inside the root. And the last thing that we're going to do is take the square root, and this is going to give me my standard deviation. Okay, so the square root of this number, it's going to be, it should be 3.25, and this is my standard deviation. This is the first value that you're trying to find. Okay, the standard deviation. Of course, all of these numbers have a lot of decimals, you know, and you have to include those decimals in the calculation. So this number might change a little bit. It might change a little bit if you include all of the correct decimals. So this is the standard deviation. These are some numbers that you're going to need for the confidence interval. You're going to need the mean, and you're going to need the standard deviation. Standard deviation. Okay, so for confidence interval, we have a little graph in there that represents all of the values, all of the porosities of all the samples that you have taken and all the samples that you have not taken. Okay, so if we want to find the confidence of, let's say the confidence interval at 95% confidence, that means that we have to know the uncertainty or the not confidence of our interval. Okay, so if this graph represents the whole thing represents 100%, we have to find with 95% confidence what's going to be the next value. Okay, so 95% of this whole graph, I'm just going to make some lines in here, right? Making or representing that this whole thing is not the 100%, but this whole thing, excluding the what we call the tails, right? This whole thing is going to be 95%. So I want to be 95% confident that my next value is going to fall in that range. So if this is 95%, then each of these tails represents 2.5%, because, well, it all has to add up to 100%. So you convert this to a decimal, that's 0.025. And this is what we call the alpha value. Okay, that's the value or the percentage of that small tail. We need this number. Okay, so the alpha value is the first thing. The next thing is going to be the same as in the standard deviation, the degrees of freedom. So this is the same thing as previously. So we have a pool of data with 7 values over here. So we have to find the same degrees of freedom, which is n minus 1. So degrees of freedom is 7 minus 1, which is 6. So these two numbers, you have to find a t-value for these two numbers. So if you Google t-table, this is going to give you a lot of t-values. Can I already Google this for you? So this is the t-table, and all I have to do is try to find which of the values corresponds to my my degrees of freedom and my alpha value. So on the top, it says one tail and two tails, right? So for one tail being 0.025, you have to find the degrees of freedom, which is 6. So if you find the correspondence in the graph, make sure in the table, make sure that you are looking at the number 2.447 or 2.447. That should be the t-value because it falls in the 6 degrees of freedom and in the 0.025 alpha value or the one tail value. Okay, if you haven't found it, this is the first blue row is the 7th column. Okay, 2.447. That is the corresponding t-value that we're going to be using in our calculation. Okay, so the t-value that we get from 6 degrees of freedom and 0.025 is 2.447. Just go back. Make sure that's 2.447. Yes. Okay, so that's the first thing that we need to find, the t-value. The next thing that we're going to calculate is going to be called standard error. Standard error. And the formula for standard error is going to be standard deviation divided by the square root of the total number of values. Okay, the standard deviation, this is a number that we got from the previous problem. Standard deviation, at least in my case, that's 3.25. This is my standard deviation from the previous problem. So 3.25 divided by the square root of n. This is not degrees of freedom, this is the total values, which is 7. So the first thing that I'm going to do, I'm going to take the square root of 7. See what number is in there. Again, I'm going to round just for the purpose of this being a little bit easier to explain. I'm just going to call this 2.65. Remember that you have to keep as many decimals as possible to keep this result more accurate. Okay, so now I have to do the division. 3.25 divided by 2.65. This is 1.226. Okay, this is my standard error. We call this standard error. And the last thing that we have to do is multiply the standard error times the t-value. Standard error times the t-value. So standard error, that's 1.226 times my t-value is 2.447. And this is going to be my confidence interval, or how far this number is from the median. Okay, so you take the t-value, you take the standard error and you multiply times the t-value, and you should get like 3.00. And this is my interval. So what this means is that in this graph, I'm going to make a sketch of the graph again, right? This number over here, we're going to call this the mean, which is 22.3. I think we calculated this in the previous problem, right? 22.3, or in the first question. And what this means is that this is my 95% confidence in between those two values, right? So what it says is that from the center to this value, there is a distance of 3. That's my interval. And the same from center to the other value. Okay, there's a distance of 3. So in order to find my interval of confidence with 95%, right, this is 95%, I have to make a subtraction and an addition, right? So I'm going to take the mean, I'm going to add the interval, and I'm going to take the mean and I'm going to subtract the interval that I just got. 22.3 plus 3, and 22.3 minus 3. And this is going to be my confidence interval. Once you do the subtraction, this is going to be the result. So first addition, that's 25.3. And then the subtraction, that's 19.3. So what this means is that these lines over here fall in 19.3 and 25.3. So what this means is that you are 95% confident that the next sample that you take, even though you just have 7 samples, right? The next sample that you take is going to be in between 19.3 and 25.3 of percentage of porosity or whatever pool of data you have. Okay, so this is the confidence interval. This is how it has to look like into your revisions for week 5.